Okay, so welcome to session 4. In this session, we'll be pulling together some of the skills we picked up from the first 3 sessions, working with some of the VIs, namely the analyze ROI image stack that we did in session 2. What we're going to be doing is introducing some more sub-VIs into that program, along with doing some extra programming to get an actual file of all of the ROI information out, as well as just modifying some of the images to help display and show how we resave images that we've been working with in Labview. So first of all, I will just, for those that have looked, the VI that we're working with is an additional add-on to the session 2. So this was in the extra section. The only difference between this ROI analysis in the extra section and the ROI analysis that we worked on is that there's like a real-time feedback, and that's achieved through preloading the images. We may not work on this one, and we may use the one that you built in session 2. This one helps illustrate some of the flows a little bit better, but we'll see in the session which one people feel more comfortable with. Okay, so quickly looking at the back end, it should be very reminiscent of the ROI analysis. We open the file path. We're using the sub-VI to organize the contents of that folder, and we're now using a particular pattern. This is just a .jpeg pattern so that we only analyze image files. We load the images, and then we go over here, and we're going to look at each of the ROIs using that pre-built light bulb application. I'll show you the little sub-VI that is quite handy to have, which just converts a global rectangle to a rectangle, so we don't need to mess around with this data set. We can just use this to switch the 2 rectangle types over. We're also going to be displaying the mean intensity in the ROI, but we're going to be collecting data from all 4. So the mean, the standard deviation, the minimum, and the maximum. We put all this all together in an array, and then we feed this array and index it through each of the cycles of the loop. We're going to write this to a spreadsheet file. This isn't necessarily what you would call a spreadsheet file. This is more of a generic numeric output. It's generally saved as a text file. The options that you get with this are things that you would see as imports into Excel, for example. Like you can choose tab delimited text, you can choose particular characters to separate the text. It's called a spreadsheet because that's generally the option that is imported into most commonly. We also have this little extra section here, which I thought would be fun. It introduces a couple of ideas that I brought up. One is zero padding file names. That's important when we start looking at large numbers of files and making sure they stay in the correct order. It's a good idea to make sure that we zero pad the file names, so that we don't have to constantly do the ordering of the files. If they're all handled in a zero padded manner, we wouldn't essentially need this ordering scheme. One other thing that I thought would be fun would be to introduce another sub-VI, which is something that I wrote along with this one, which is to false color the images. So let's just say we have a red image, but we want to display it in green. This will allow us to display it in green. Then we're just going to save those images to a particular location. As with previous sessions, if you want to go ahead and look at things, you just double click on the sub-VI, and then if you want to see the details, we just show the background. this is kind of what that sub VI does. Let's just close that off. Okay, but what we're aiming to achieve, we might not have this preload configuration. We might just have the run-through configuration. However, what we're going to achieve is we're going to pick a file which belongs to a certain folder type. We're then going to choose a pattern of the files of interest. So first it's just .jpeg, but we might have like a channel specifier as well if it was a confocal image. Going to choose a color for what color we want to make our new images, and then we're going to capture all of the ROI data for those files. So let's just go ahead and run it and see where we get. Okay, this is just another one of these great files by Celine. I mean, just delete all these ones. As you can see, this is ones I've done previously, and we have all these bluish images on the bottom. So we'll just go ahead and delete those because we don't need them. It won't let us do that there, so let's do it here instead. All I'm doing is deleting files that I made just when I was testing the program. Okay, so we choose the folder path. You just pick a file that you like the look of. Let's say this one. Okay. And we run the program. If this is right, then hit OK. And we have our little ROI tool. And if we're monitoring over here, we should be able to see as we move around, it moves around in real time, showing us kind of how the details change in that region of interest. But I think we're going to hang around here. That looks quite interesting. This color seemed quite nice to me. All we have right here is a grayscale image, but this is just a representation. The actual image is red, as I shall show you here in the original file. The representation is shown as a grayscale on the front panel, as the intensity analysis will only work on black and white images, because a red image has 3 channels and it doesn't know which channel you are asking it to analyze. We can extract a color plane when we want to find out a particular piece of information, but grayscaling it for these single channel images works perfectly fine. So okay, we're going to switch it from red to, I suppose, this kind of cyany blue color. And this takes a little while to save the images because it's actually doing quite a lot. Not only are we opening the image and then we're up converting it to a higher bit depth, we're also changing the color type. The reason why that's important is because we're switching it to a HSL image instead of an RGB image. And if people want to know the specifics of why we're doing that, then I will gladly explain it. But for now, we can just treat it as, instead of a typical false color that you're used to seeing in lots of programs, I mean even Photoshop will do a false color. Instead of a traditional false color, we're doing what I would like to call a data maintaining false color. So we're able to give it all kinds of different colors, but we're still retaining all of the original intensity information from the original image, and that is not the case with regular false coloring. Anyway, enough about that. That region of interest looks good. Let's just make sure. Yeah, that one looks pretty good. Well, maybe we should do this one. It's got a nice little spike in it. Then we hit ROI OK. And then this one to the right, you'll see it's slowly ticking down. And if we go to this folder, we should see these files start being made. So it's now remaking all the files. Pay attention to the file name. You know, this file name is now changed. It's been 0 padded so that the little sub-VI that I've written to actually 0 pad looks at how many files there are, so it knows how many zeros to put in place. And it's just going to chug along and make a whole nice set of new images in a different color, if that's something that you needed. I'll let this finish out just so the program finishes. But that's essentially what we're going to be working on. We're going to have some new sub-VIs, one of which you've written, 3 of which I believe are ones that I've written. Going to combine them into a program that you've previously constructed for ROI analysis. We're then going to modify that program so that we can output a modified image, in this case a colored image, but we're also going to output the data for each of the regions of interest. I can actually show you what right now. So we get an extra little data analysis text file, and here we have this data outputted. So it goes mean, standard deviation, minimum intensity, maximum intensity, and then each new line is a different frame. And if you scroll down, you can kind of get a general idea of how it flows. And this you can just pull straight into Excel. So there we have it. It's going to be a information-rich session. As always, try to watch both sessions' videos, because you might be able to pick up on something from one session that you didn't pick up on in the other session. Normally that's me going too fast or too slow. So yeah, watch both sessions, and hopefully you'll be able to start outputting the data that you do when you do Labview. Okay, thank you.